So to get started today, you are going to first write down the numbers on your board area there, the following numbers: 17, 2, 21, 3, and 8. All right, what I want you to do is, so that each of them are like individual parts of this problem as you're thinking about it. Using the numbers 1 through 10 exactly once each, or not, you don't have to use all of them, but using the numbers 1 through 10 only once, and you can use add, subtract, multiply, divide, try to hit those target numbers. Right? So like if you're looking at the number 2, you can go 5 minus 3. Boom, that's 2. Okay? There's going to be easier ones and there'll be harder ones. If you get one that's really easy, after you get them all done, come back and then see how many ways you can do it using just the numbers 1 through 10. And then there will be probably faster ways of doing it and then some that might be a little bit more complicated. So start to put yourself in that mindset of like being a little bit more complicated with your add, subtract, multiply, divide. All right? Does that make sense? All right, go ahead and get started on that. So, again, write them down, simplify them. All right, so let's go through these as you're looking at your own boards. With your own groups, you're at your own boards. 10 over 2 is 5. 2 times 5 over 2, a couple different ways you could do this. Remembering PERMDAS, P-E-R-M-D-A-S, or PEMDAS if you learned it that way, but the R means roots. We don't have any roots in this equations. But you have to do what you have to do first. So some people divided the 2 divided by the 2. Some people did the 2 times 5. Since it's only multiplying and dividing, you can do them interchangeably. All right, but I think a lot of people did 10 over 2, which is also 5. Then you've got 2 plus 12 over 2. Can you reduce the 2 and the 2? Shake your head and say no. No, you cannot divide just the 2 and the 2 because it's trapped with addition in the numerator. So although the numerator doesn't have parentheses, they are technically there. Anytime you have a big fraction like that, it means everything in the numerator has a parenthesis set around it. So you first have to do the 2 plus 12. And since that simplifies to 14, you'd have 14 over 2, which is 7. The next one down, again, we're only multiplying and dividing. So if you just reduce the 2 and the 2, you're left with 9. Next one down. Can the 2 and the 2 reduce? Everybody nod your heads and say yes. Yes, they can. Why? Because they're being multiplied. They are being multiplied. 2 times a whole parenthesis set, and then you're dividing by 2. The 2 over 2 can reduce, leaving you the 3 plus 8, which is 11. Or you did 3 plus 8 and you got 11 times 2, which is 22 divided by 2, and you got 2 that way. But the reason why we're doing this is it's going to lead us into what we're going to be doing more complicated mathematically today, which is rational polynomials. All right, top of the next column, what's my answer? 5x. What's my next answer? X. And my next answer is not x, because I have 2 plus x divided by 2. So I can do it one of two ways. I can look at that and say, there is nothing that's being multiplied and divided equally in all of them, so I just do nothing with it. Or, this is what we're probably going to do instead, is we're going to split it up. We're going to separate out the fraction. So I'm going to have 2 over 2 plus x over 2. So if you didn't have that, write that down now. So you're basically splitting that fraction up so that right now, 2 plus x over 2, that has one denominator. I can split it up as 2 over 2 plus x over 2, because those two fractions have the same denominator, and if I wanted to, I could combine them into 2 plus x over 2. Now, what is 2 over 2? 1. So I'd have 1 plus x over 2, and that would be my final answer. What's the answer to the next one? X. And then my last one. I'm going to simplify the numerator first. Can the 2 plus x combine? No, they're not the same terms. So then I'm going to use the 3 and I'm going to multiply, distributive property. 6 plus 3x all over 2. Now I'm going to split it up into two different fractions. 6 over 2 plus 3x over 2. And again, if you didn't have that, you're going to write that down, 6 over 2 plus 3x over 2. Then you can simplify the 6 over 2. Final answer, 3 plus 3x over 2. Now, next thing up, we're going to start doing polynomials. We talked a bit about polynomials already, coming back to it again today. Going to spend some time in here. And I say this, polynomials are to algebra. So we've done algebra. You've done lines, you did equations. You remembered on the exams, I think one of the groups was already talking about it. Oh yes, same slope, that means they're parallel. So how do you prove two lines are parallel? You find the slopes of the two lines, usually by putting it in slope-intercept form, and like, oh, they have the same slopes, they must be parallel. Or if you take the two slopes and multiply them to get -1, that means that the two lines are perpendicular if you have their two slopes. So that was, kind of getting going with algebra and graphing and then solving equations, solving inequalities. You remember that, if it's a greater than symbol, that's a dashed line when I graph it, things along those lines, all right? But when you learned arithmetic, add, subtract, multiply, and divide, where we started today, we take that and we kind of advance it into algebra, and now we're going to take algebra and we're going to advance it into polynomials. So what we're going to do with them is we're going to add, subtract, multiply, and divide them, just like we did today with, first it was just the numbers, arithmetic, and then we added variables, so that was algebra, and now we're going to take it another step forward. So rational expressions, those are both examples of rational expressions. This is a rational expression, this is a rational expression. What does it really mean? It's a ratio. So when we say rational, we're talking about it being a ratio of two algebraic expressions. All right, so what do I mean, algebraic expression? Now, 2 is just a number. So is it an algebraic expression? It's like the weakest form of one, but it is one. You say, well, is there a variable here? And we don't see it, but if we wanted to, and I'm going to just draw it in super quick, if I have x to the 0 power, anything to the 0 power is 1, so it'd be 2 times 1. But I normally don't write that, so I'm just not going to. But it is part of that expression. And then in the numerator, we have a binomial, 2 terms. Here we have a binomial, and in the denominator we have a quadratic. But when we're dealing with rational expressions, just like this, and we're simplifying and things along those lines, the first thing we're going to do is factor. Why do we factor? Because later we want to simplify. And factoring, which is what we just did the last last chapter, basically. Chapter 5 was a lot on factoring quadratics, factoring polynomials. So we're going to start with this and say, can I factor the numerator? So I'm going to look at 3x plus 7. Do they both have something in common? So I'm going to do the whole factoring process with the numerator, and then I'm going to do the whole factoring process with the denominator. Is there a GCF? No, there's not, because 3 and 7 are not both divisible by the same thing. This has a variable, this one does not. This cannot be factored. Does 2 have a factor? Well, just 2. So it is done in terms of factoring. The second thing we're going to talk about is the domain of the function. It's not a function yet, but soon we're going to use function notation. Domain means, is there any number that I cannot put into this fraction? All right, so in this case, you can put any number you want in there for x. Any number you want for x, and it's going to give you a result. When we get to this one, we're going to find out that there are numbers that we can't use. Ooh, my pointer is not following along. When we get to this one over here, the numbers that we cannot use, you cannot have a fraction that ever has 0 in the denominator. 0 means undefined. Well, if it's not defined, that means we can't have it. So that's where we're going to get to. So first thing first, we factor. Then we talk about the domain. There's no domain restrictions here. After we talk about domain restrictions, then we'll simplify. So let's work through this one quickly. So again, if you're like the note-taking type, yeah, maybe write that down. And we're going to walk through this relatively slowly. And then we're going to pick up the pace because we're going to have a lot more of this same idea as we're going to go along. But we start by, again, we're going to first, and again, if you're like the person who likes to have, what do I do first? What are my directions? The first thing first is we're going to look at the numerator only. And we're going to go through the factoring process. So we go, all right, 7x minus 2. Is there a GCF? Is there a greatest common factor? Do 7x and negative 2 have something that both can be divided out of each of them that's the same? And we look at this and go, well, this has an x, that one does not, so I cannot divide the x out. 7's odd, 2 is even. There is nothing I can do for a GCF. So there's no GCF, and this is not a quadratic or anything else. It's just a linear equation or a linear expression. So that one is already factored as far as it can go. So 7x minus 2 is going to stay 7x minus 2. So down here, I'm going to go 7x minus 2, and I'm just going to leave it like that. Then over on the right-hand side, I'm going to grab just the denominator, 2x squared plus 7x plus 6. And I'm going to look at that and say, okay, can that be factored? Or is there, we start with, is there a greatest common factor? This has an x, this has an x, no x's, so I cannot factor an x out. Even, odd, even, they are not all the same, so there's not a number I can divide out of all of them. 2, 7, and 6 do not have a number you can divide out of all three of them. So there is not a GCF. Second step of factoring. Is this one of the special looking quadratics? It's a quadratic. The x is squared, that's how I know it's a quadratic. Is this one of the special forms? And the answer is no, it's not. The special form that we typically have had is something like x squared minus 25, or x squared minus 9, or x squared minus 100, where the second number is something squared. So it's not one of those forms. So then I go through the trinomial factoring process. I'm going to do a times c, and that will be 12. A is 2, 6 is c, so it's 12. The a is the number in front of the x squared, the c is my last term, the constant term, the one without the variable. So it's 12. And now I want to look for two numbers that will add to 12. Two numbers that multiply to 12 that add to 7. So I try numbers like 6 and 2. 6 and 2 multiply to 12, but they add up to 8. That doesn't help me any. Three times 4 is 12, and they add up to 7. This is what I'm going to use, and then I'm going to do factor by grouping. So remembering what that means, it means I take this equation, 2x squared, and the 7x, I'm going to split it up into 3x, because that's what the 3 is for, plus 4x, because that's what the 4 was for. So I'm essentially unsimplifying. I'm splitting that 7 up into 3 plus 4. And then at the end, I still have plus 6. So again, just took this original equation, and the 7x, I split it up into 3 and 4. If you try to do 6 and 2, you're not going to get the right answer. You won't get an answer. All right. So it's very specifically, you got to follow the A times C, first term times the last term. That gets you to the 12, and then the two numbers that multiply to 12 that add to the middle term. So then, the factor by grouping means I'm going to take these two and these two and factor them separately. So I start with 2x squared and 3x. Is there something they have in common? They both have an x. Are 2 and 3 divisible by anything else? No. So I'm reverse distributive property, or factoring it out, 2x plus 3. Again, just factored that x out of both of those terms. I have positive 4 and positive 6 next. So I'm going to factor out a positive 2. And there's no x's in both of them, so that's the most I can do. And I'm left with 2x plus 3. And if I've done this the right way, whatever I end up with in parentheses will be the same thing. That's what factor by grouping does. So now I have this whole term plus this whole term. Terms are things that we add. So I can think of this as giant thing, this is a giant thing. Are they both divisible by the same thing? Yes. Both are going to be divisible by 2x plus 3. So I'm going to factor out 2x plus 3. When I factor that from the first one, I'm left with x. When I take the 2x plus 3 from the second term, factor it out, I'm left with the positive 2. So now over here, my denominator will be 2x plus 3 and x plus 2. And parenthesis, I'll put parentheses up there just for consistency. You don't have to, but it's not a bad idea. All right, I did the first step. I factored. Second step, we need to talk about the domain. Are there any numbers that will make the denominator 0? The answer will be yes. Here's how I go about figuring that out. I'm going to take each of the items, or each of the factors. I've got 2x plus 3. I'm going to set that equal to 0. And find out what makes that 0. The reason why, because like we did when we factored before, we were factoring to find the zeros of an equation. Now I'm finding zeros for the domain, what we call domain restrictions. Because if this is 0, 0 times anything is 0. If this is 0, then 0 times, so we're going to set this equal to 0 and solve it. 2x equals negative 3. Subtracted 3 from both sides. Divide by 2. X is negative 3 halves. Well, I'm not going to actually box that off yet. So x is negative 3 halves. When x is negative 3 halves, if I were to put that back up here in my original equation, I would get something divided by 0. And that would be undefined. And that will be one of my restrictions on the domain, which we'll finish in a moment. Then I take the other one, x plus 2, set that equal to 0, x equals negative 2. So my domain will be from negative infinity up to negative 3 halves. Oh, sorry. Up to negative 2, because negative 2 is smaller. From negative 2 to negative 3 halves, and from negative 3 halves to positive infinity. All right. If you've not seen that notation before, I'll show you what that means in just a second. But the other way to say this is it will be x cannot equal negative 2, x cannot equal negative 3 halves. And then it will be every other number except for those two. Now I'm going to move everything out of the way for just a second. We'll come back to it. My equation was 7x minus 2 over 2x plus 3 and x plus 2. If I were going to graph that, if this was y equals, at negative, so this is negative 1, this is negative 2. At negative 2, there's a dotted line, there's what's called an asymptote. At negative 3 halves, which is negative 1.5, there's another one. And that means that the graph will be something out here that will come close to this line, either down below or it'll come up and it'll go up above. There will be something in here, and there will be something out there that will be curves that go in certain directions. But it'll never cross this line. They're asymptotes. So we'll talk about some more graphing later, but that's what's going on. So the restriction on the domain is, as I'm on my graph, if I put negative 2 in there, I'm going to get 0 in the denominator, and anything divided by 0 is undefined. Your calculus says, yeah, it can't happen. What's actually happening is the line is approaching infinity because it's going to get really, really close and then go high. And then same thing here. As I approach this way, and it might go to negative, where it goes, oh, it's going way down here. Also possible. But that's what a domain restriction means. Let's go. Can I get everything? There we go. Bring all that back down. And then the last step would be to simplify. That is there something in the numerator that is identical to something in the denominator? And here's where I'm going to see mistakes happen a lot. So I'm going to tell you what the most common ones are, which several of you did today when you were doing the fractions on the boards. Most common mistake I'm going to see is people go, oh, this 2 and this 2 reduce, and that is egregiously wrong. Not just wrong mathematically, that's like horrendously wrong. So don't do that. If it's inside of parentheses, or if it's not, like even if this numerator did not have this parentheses set, because I said technically it's not written, this is trapped with subtraction. That 2 is trapped with subtraction. It cannot be divided by anything down here. This 2 can never reduce that 2. The other reason why is this 2 is also trapped with addition. So the only time you can reduce is if it's being multiplied. And in this, I have 3 things that are being multiplied. I have A, which that's just a generic A. A means 7x minus 2. That I'm just calling, that's that whole thing. I also have in the bottom a 2x plus 3, which is a B, because it's different than 7x minus 2. And I have an x plus 2, which is a C, which is also different. There are 3 different things being multiplied. If I just had this, A cannot reduce with B, A cannot reduce with C. There's nothing that can reduce here, which is why nothing reduces here. But again, I'm looking at it and saying, I got this whole thing, I've got this whole parenthesis set, and then this whole parenthesis set. Altogether, none of them can reduce the entire thing. Again, because they're being multiplied, there's a multiply there. Or divided, giant division symbol. Since that cannot reduce, there's nothing else that I could simplify. So this is what we're going to do. I'll work on this one again. And then the next slide, you're going to get a little chance to practice on your own or with your group that you're sitting with. So I start with saying, okay. Step 1, factor. I'm going to look at each individually. I'm going to look at the 6x squared plus 1 and say, all right, 6 and 1 do not have a common factor. This has an x, that does not. So I cannot do a GCF. And then I look and say, all right, is there a way to simplify, like, is this a common form of a trinomial or of a quadratic? The answer is no. Then I'm going to go to my factoring processes, and I'm going to do it a times c. And some of you might be looking at this and saying, but there's no middle term. There is a middle term. That's plus, and then there's a 1. The middle term, there was no x term, which means that's a 0. A times c is 6 times 1, and that's 6. And then I'm looking for two numbers that multiply to 6 that add to 0. Because the middle term is 0. Has to multiply to positive 6 and add to 0. 2 times 3 adds to 6, or multiplies to 6, but it adds to 5. You might say, well, what about negative 2? If it's negative 2, the other one has to be negative 3 because they have to multiply to a positive 6. And these add up to negative 5. And what we realize is there won't be one. Again, I could do 1 and 6. That adds up to 7. So what does that mean? That means my numerator cannot be factored. It will stay as 6x squared plus 1. Look at the denominator. Do x and 3 have a common factor? No, they don't. Is it a quadratic? No, it's not. It's not a trinomial either, so it also stays as x plus 3. So step 1 is to factor, and we realize we cannot factor it. Well, that's nice. But then that usually makes everybody worried that they did something wrong because they think, well, it has to be able to factor. Not always. So step 1 is factor. Step 2 is domain restrictions. I'm going to look at the denominator and find out where the denominator equals 0. Negative 3. The denominator is 0 at negative 3, which means my domain will be all real numbers except negative 3. Or, officially I should say, except x equals negative 3. So in the last problem, I would have said my domain is all real numbers except where x was negative 2 and negative 3/2. Yes, using words. Can you simplify this? Are there other mathematics, that symbol to mathematicians means all real numbers. Okay. Set notation would be negative infinity up to, didn't want to go parenthesis, up to negative 3. Or negative 3 up to positive infinity. That's set notation. If you're going to be taking pre-calc next, you're going to want to pay attention to this because once you get to pre-calc, set notation's pretty common. We stop using the words. We start using this kind of stuff. All right. And this means from negative infinity up to 3. The parenthesis means I'm not including 3 because when I am at negative 3, I have 0 in the denominator, and that's undefined. If this were a bracket, a squared off bracket, that means I would include negative 3, but I don't in this case. All right, and then I go, after I've done the domain restrictions, I look to see if I can simplify. Well, here's your big hint. If you can't factor, you're not going to be able to simplify typically. All right. There's going to be some of you that are going to write down and try to reduce this x with this x squared, and again, horrendously wrong. Like, that's a big mathematical no-no. Equivalent to say, well, I'm just going to decide I'm going to drive on the left side of the road now because I think I'm in England. You're not in England. Can't do it. Bad things happen. All right? So, and this 3 cannot reduce with that 6. They are being added. And the only time you can reduce if it's only multiply and divide. So next up, I would like you to give this one a try on your own. Well, on your own if you're in class with the person and people you're sitting next to. Use them as a resource. If you were in a group solo, you are welcome to talk to the person next to you. See if you can do that following the steps. This is function notation. Like on the last one, we have f of x. This is h of x. This means the function of x, or the function of h with respect to x. All right, so function notation, but what that means is, whatever you put in for x here, h of 2 would be like if I put 2 in for x and found that. That's not what we're doing here, but we're going to use the process of simplifying. Identify the domain, do some factoring. On your marks, get set, go. Let's see how we're doing. Some of you are at the board, some of you are in your seats, but you start with factoring. Start with the 2x squared. 2x squared is a single term, which means it is already factored. As a single term, you can't factor a single term. It is just 2 times x squared. So it stays as my function here, h of x, it will stay as 2x squared. In the denominator, there's a 10x cubed and a 2x squared. Do they have a GCF? Yes. 10 and 2, both divisible by 2. X cubed and x squared are both divisible by, I see your work, x squared. When I factor that out, it's left with 5x minus 1. And again, if you're wondering, like, hey, did I do this the right way? The double check is, when you've done the factoring, if I do distributive property, 2x squared times 5x, well, 2 times 5 is 10. X squared times x is x cubed, that's good. 2x squared times negative 1 is negative 2x squared. Right? So again, when we're factoring, finding a GCF, we're just doing reverse distributive property, or unsimplifying. So now I have this, and then I look, is this any more factorable? No, it's not a trinomial. It's not a quadratic, it's just a binomial. This is factored. And if I use what I did on the other page and say, all right, in the numerator, I have one thing. I have a 2x squared. In the denominator, I've got a 5x minus 1, which is its own thing. In the denominator, I also have a 2x squared, which is the same as what's in the numerator. So when I get to simplifying, I'm going to come back to that. But before I do that, I have to determine my domain restrictions. I have 2 things in the denominator that are being multiplied. So I'm going to set it up as 2 separate equations. 2x squared equals 0. 5x minus 1 equals 0. X squared equals 0. If I divide both sides by 2, square root it, x is 0. Which means for my domain restrictions, x cannot be 0. Because if I have 0, 10 times 0 is 0, minus 2 times 0, well, 0 times 2 is 0. 0 minus 0 is 0. I have a 0 in the denominator. My function is undefined. The next one, 5x minus 1, so 5x equals 1. Added 1 to both sides. X equals 1/5, or in this case, we're saying x cannot be 1/5. So my domain restrictions, I would say all real numbers except x equals 0 and x equals 1/5. All real numbers except x equals 0 and x equals 1/5. And then my last step is to simplify, which is this. I have three things multiplied. I have this in the numerator, this in the denominator, this in the denominator. Again, the a is representing the 2x squared, which is also down here. And again, all that's happening is in between the parenthesis and this is multiplying. A divided by a is 1. So that's 1 over b, or in terms of what this equation function is, h of x equals 1 over 5x minus 1. And if I were doing set notation, negative infinity up to 0, 0 to 1/5. So in that narrow little interval, 0 to 1/5, the function's going to do something. And then 1/5 to positive infinity for set notation. I'd put a comma in between here. In the last slide, I used the union symbol. You could use the comma. Sufficiently okay. Some mathematicians would say no, they're not. But for my sake and most of what you're going to see, going to be okay. All right, I'm going to do this one. What I recommend you do is just follow along. Ask a question on your piece of paper. If you're like, wait, how, what? Write that down so when I say any questions, you can ask that question. But this is all on video, so you can copy it down later. Don't spend your time trying to copy things down. So g of x is equal to, and I'm going to go 2 times 9 minus x squared, because that's the GCF in the numerator. And then denominator, this is a binomial or a trinomial. And since my coefficient here is 1, I'm thinking of two numbers that multiply to -3 to add to -2. Oh, that's x minus 3 and x plus 1. I can factor that one really fast because these two numbers, 3 and 1, -3 and 1 multiply to -3. -3 and 1 add to -2. I didn't have to do the AC process. But my numerator is not completely factored because the numerator is a special type of quadratic. That's a difference of squares. That means the numerator would factor into 3 plus x and 3 minus x. In the denominator, I have x minus 3. I have x plus 1. My domain will be all real numbers except x equals 3 and x equals -1. Because if I put 3 into x minus 3, I get 0. If I put -1 into x plus 1, I get 0. Can't have those two numbers. Last step, I'm going to look at this here, and I've got 3 things being multiplied in the numerator. I got a 2, I got this parenthesis and this parenthesis. I have this parenthesis and this parenthesis. None of them are identical, but there's one of them that's actually pretty close. This is close to that. So is there a way I can take this and make it into that? The answer is yes. If I take a -1 and factor it from each of those terms, it would be then -3 plus x. Because factoring is reverse distributive. So I just changed the sign of this. I changed the sign of that. I factored a -1 out in front. So what that means is that my numerator would now be h of x equals -2 times x plus 3. I just took this and rewrote it as, instead of 3 plus x, as x plus 3. When I factored the -1 out of the other one, I moved it down too far, didn't I? There we go. It was x minus 3. Denominator, I have an x minus 3 and an x plus 1. Now I have the exact same thing, numerator and denominator. Those will reduce. -2 x plus 3 over x plus 1. That would be my final simplified version of the original equation that was listed. And of course, we're going to get more complicated. This is not going to be listed as a function, so here this would just be simplifying. process is going to be very similar, except when we're only simplifying, I don't need to talk about the domain. So first thing first is I'm going to look at this and say, I can do factoring. This is a difference of squares. That's x squared, that's 5 squared. So this will become x plus 5, x minus 5. In the denominator, x plus 5 squared is the same as saying x plus 5 times x plus 5. Square means times itself. Biggest mistake I'll see is people will say, oh, it's x squared plus 25. No, it is not. All right? Times 3 times x plus 5, because they had a common factor, over 4x, that's a single term. Then I have a divided by, which we don't like that with fractions, so we do it as multiplying. Dividing by a fraction is multiplying by the reciprocal, which is x over x squared minus 3x minus 10. But wait, that's a trinomial. It's a quadratic. It can be factored into two things like this, two numbers that multiply to negative 10, that add to negative 3. And again, I don't have to do the a times c process because my first coefficient is 1. Numbers that multiply to negative 10, negative 5, and positive 2. Now again, I've been doing this like a bazillion years because I'm old. It might take you a little bit more time to go, wait, how did you get those two numbers? 5 and 2 get me to 10. And then since negative 3 is the middle number, the larger of the two has to be the negative value. Because negative, if this middle number was positive, then it would be negative 2 and positive 5. But now I have a giant fraction. And we'll do it in yellow here. I have x plus 5 times x minus 5. There's another x plus 5, and there's also a 3. I'm going to throw that in there. Oop, actually, let me do this. There's a 3x. So in the numerator, I've got x plus 5, x minus 5. I got another x plus 5. I got the 3 and the x as individual items. I'll put them out in front. In the denominator, I have an x plus 5, another x plus 5, the 4x I'm going to throw out in front, and the last one is x plus 2 and x minus 5, because that was from this one over here. So that's all of my denominators. Again, when we're multiplying fractions, multiply the numerator, 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 all the way across, denominator, denominator, multiplying. Now I get to reduce. Do I have anything identical in the numerator that's in the denominator? Yep. I got another x plus 5 right there with the other x plus 5. I got the x minus 5 and the x minus 5. I have right here an x and an x. They're going to reduce. And at this point in the numerator, I have 3. In the denominator, I have 4. And I have x plus 2. And then that would be the finished form for that being simplified. Remember adding and subtracting fractions? Same denominator, I can just add them. 4/8. X plus 1 over 8. Oop, different denominators. Need to change it to 6/8 plus an 1/8. All right. So that's going to give me 7/8. Oop, got to change the denominator here. 2x over 4. So I multiply both numerator and denominator by 2. Oh, that's not a 4 on the bottom. That's an 8 in the bottom. Because I multiplied the numerator and the denominator by 2. I multiplied this by 2 over 2. What is 2 over 2 equal to? 1. So when I multiply by 1, I'm not changing the value. I'm changing how it looks. All right, so I just multiplied it by 2 over 2. I multiplied it by 1. It's still the same thing. But now at least they have same denominators and I can simplify. into one fraction. My denominators over here then are obviously much different, x and 8. So I need to multiply the first one by 8 over 8, the second one by x over x. So that way I'll have 24 over 8x plus x over 8x. Now I've got the same denominator. Now I can add them up, and I'd have 24 plus x over 8x. This needs an x over x. Multiply it by 1. I'll then have 3 plus x over 8x. They're the same denominator, which is fun and easy. I can just do 2 plus x. Paying really close attention, that's a plus, so make sure we're adding there. 2 plus x over 7 minus x. And that is simplified. Do not reduce those. Much like we've said before, they are trapped with subtraction here, addition there. It's not multiplying, so they cannot reduce. They can only reduce if they're multiplying, like we did on the last slide. Uh-oh. Now they're different. This becomes a little bit bigger. I'm going to finish this one first, and then I'll come back to this one. So this one, same denominator. So I'll have x minus 5. It's minus, so it's minus x. It's minus the 5 as well. That's over 2x. That's what I mean. Pay attention to those negative signs. X minus x is nothing. Negative 5 minus 5 is negative 10 over 2x. That can reduce to negative 5, negative 5 over x. Because the 2 can divide into the 10. Again, they're only multiplying. That's why I can do that. This one, I need to have a different denominator. This first one, I'm going to multiply by 7 plus x. Because that's what the other equation had in its denominator, or the other expression. This, I'm going to multiply by 7 minus x over 7 minus x. Again, 7 plus x over 7 plus x. It's the same thing. So I'm multiplying it by 1. It's just a really fancy looking one. This one, a really fancy looking one. Bring this one down here. So I'll have 2 times 7 plus x in the numerator. In the bottom, 7 plus x, 7 minus x, plus, then I'll have x times 7 minus x over 7 plus x, 7 minus x. They now have the same denominator. Then I can add them up. 14 plus 2x plus 7x minus x squared. Which was distributive property. In the denominator, I'll just leave it as 7 plus x and 7, that's an x. 7 minus x. Numerator simplifies to negative x squared plus 9x plus 14 over 7 plus x, 7 minus x. And we're almost done. Because that numerator is a trinomial. Can it factor? But this is a negative out in front, which we normally don't like. Going to rewrite it as negative x squared minus 9x minus 14. Factor a negative from each of them over 7 plus x. Sorry, my x, 7 minus x. So then I go, oh, negative 14. Are there two numbers that multiply to negative 14 that add to negative 9? Unfortunately, there's not. Our instinct would be, oh, 7 and 2. But in order for it to multiply to negative 14, one's positive, one's negative. So really close to having one that would simplify further by factoring. And then if it factored, I could do some reducing, but just not quite there. When we move on to these, sometimes it's easier if I can factor first. 2 over 3 times a plus 3 plus 5 over 5 times a minus 3 these can reduce because they're being multiplied. So now my new denominator, when I'm done, my final denominator will be 3 times a plus 3, a minus 3. Which means my equation on this side, in order to get the a minus 3, well, that's already in the denominator, so it doesn't need any more. But this one needs an a plus 3 and a 3. So this will multiply by 3, a plus 3, 3, a plus 3. This one needs, well, it's already got the 3 and the a plus 3. It only needs the a minus 3. Again, what we did with fractions back in elementary, middle school, it's carrying over now into polynomials. We're still doing add, subtract, multiply, divide. We're still doing factoring. It just becomes a little bit bigger, a lot more steps. It's okay to take up a lot of paper. You probably should be. So on the left-hand side, I will have 2a minus 6, because I did distributive property, plus, on the right-hand side, 3a plus 9. Numerator simplifies to 5a plus 3, negative 6 plus 9, over 3 times a plus 3, a minus 3. There is nothing there that can reduce because 5 and 3 are not divisible by the same number. This 3 cannot reduce with that 3. That's adding, not multiplying. These are the problems that you should be doing for 6.1 and 6.2 that are related to all that we did today. And I'll say this again. It's called Check Your Understanding because you are doing all the problems. They're all odd numbers, so you can check to see that you got the right answer in the back of your book. Or if you're on the online version, same thing. If you don't understand that and you're not getting those answers, check with someone in the class, work with them, set up a time to meet with me. But if you choose not to do these, then you are missing out on where I get most of my exam questions.